Folks, to week 5. Yes, week 5. And today's actually there's no demo today. It's actually slides, so there's that. It's the last set of content for the midterm. I'll give the midterm information first so that if I run out of time at the end, it's not going to be lost. It's going to be here in class, on paper, multiple choice. You're going to circle shit on a piece of paper. I'm not going to bother with Scantron because for 13 people, it's not worth my time. Considering I'm leaving town the day after at noon, I don't have time to wait for them to scan them, so I got to do them all by hand that night. I'm going to go through the exam next week in better detail. That being said, if you have any kind of accommodation for test taking, you probably want to book that today, or by tomorrow or whatever. And your test will be at 4 o'clock on Thursday, the 19th, I believe it is. Yes. So 19th at 4 o'clock in this room. 50 minutes, not 1 hour. It's 30 questions, 50 minutes, 30 questions. I'll go explain the timing, why that time is set the way it is next week. Okay. Now to dive into today's topic, so I make sure I actually do get the stuff covered. It's a bit of it's going to be some review from stuff you did at the beginning of the term. Now that you've played with queries and stuff and seen data, this might make a little more sense. All right, so this isn't really the review, but it's a bit of a review right at the start of the slides. So right now, you know how databases now organize stuff. It basically looks like Excel spreadsheets. Basically, they're tables with with rows and columns. Now, the topic today actually is about data integrity, and data integrity is about making sure that your data is safe and that you don't corrupt the data or you don't allow invalid data to go in. So inside of database systems, there's 4 types of what they call logical integrity. There's entity integrity. That's your primary key. That's making sure that your entities, your instances are unique. Your rows of data are unique. They can be uniquely pulled, edited, and put back. That's to make sure things are unique. Referential integrity is to make sure that relationships between tables are valid. After the break, you're going to learn how to query more than one table at a time, and referential integrity is what allows that to happen. Domain integrity. Domain integrity means a few things. Part of it's the data type, so that you're not trying to shove an integer into a string kind of thing. But there's also things like, is it null, not null? Are you putting in a check constraint on it or not? There's a few different things with that. And then there's user-defined integrity, which we're really not going to touch very much today. But you can actually set up unique rules that is not specific to the database. You set up extra routines to make sure things are maintained. Yeah, so literally I just finished explaining those things. But yeah, the user-defined integrity is also listed here with a bit more detail. It's basically rules and constraints that are created by the user for their specific purpose. For example, you can set up a rule that says in the date of birth field, it can't be in the future. So you can set up rules like that saying when the data goes in, you're not allowed to predict that somebody's going to be born on a certain day. Anybody who's ever had kids knows there's no way to predict the day that kid's coming out. Yes. Like, yeah, well, time sensitive data, that depends. It depends what you mean by time sensitive. Timestamps? Yeah. So you can do the same thing there where you're not allowed to put things time in the future, time in the past. Time series where you're entering multiple rows, where every time you add a row, it's not allowed to have a timestamp from before. You can set all kinds of rules, pretty much whatever you want, within reason. Um, Historically, that was often put right in the database, but as modern systems are coming around and people are starting to go, well, we want to be able to define the rules ourselves. So instead of having to get a database admin to go modify the database structure, they set it up so your software can set up the rules. I don't know if you've ever set rules in Outlook, for example. In your email, you can set up rules to do all kinds of things. Like email comes in with this subject line, put a flag on it, automatically put a reminder, that kind of thing. Or email comes in from a specific person, just delete it. There's all kinds of things you can do. You can do similar things inside the database. Okay, so on this slide, it shows pretty much several kinds of integrity checks. So we've got a primary key, which is, I'll draw it right on the screen. So our primary key is right here, right? So that's make sure it's unique. It's also listed down here, some unknown reason, but it shows it here too, but it's the same thing. We have two checks on the person's age. The person must be 17 to be put into the employees table. Maybe it's a company where they don't hire anybody under 18. And the net income is where the overtime is less than the salary. In other words, they're not allowed to actually earn more in overtime than they do in their salary. Those are some of the checks they have set on this. Now, in this one here, we have the primary key again, the department number. Well, here we have the department name, and you can, no, that was interesting. Mouse decided to jump. The department name you'll notice there's a key next to it. That's saying it's a unique key. In other words, the department name is only allowed to exist once. Those are, and that's right down here. You can see right down here that there's a special index. I don't know why my mouse is jumping. There's a special index that says department name must be unique. That's just to avoid duplicate data in sensitive fields. In some systems, they'll put a unique, for example, on the email address, where a person cannot have the same email address twice, or the same address can't. You go to a website and you go to register and it says your email is already there. They're probably doing that with the application code, but you could actually do that in the database, and the database rejects it. So that if the application developer screws up and manages to allow that to happen, the database will still reject it by enforcing rules at the lowest possible level. Hey, so referential integrity is the series of processes to store and access data uniformly using relationships. So what it does is it makes sure that data is consistent, especially if you're using things like reference tables. An example of a reference table: list of provinces, list of countries, titles like Mr., Mrs., Miss, whatever. Shipping methods could be another reference table. This order was shipped by FedEx. You don't want people typing that in every time. Therefore, use reference tables with foreign keys, and that allows for a few things. If you suddenly have to rename things, it's handled by renaming it in the reference table. You only need to change it in one place, and everybody gets the changes immediately. It's funny, I just literally had this conversation with a co-op student at work today. Again, I had a very similar conversation last week with my other group. So it also makes sure that things stay consistent and clean. Essentially, that's what foreign keys are for. So how is RI, or referential integrity, established? You use two keys, and you have a primary key, which is on the source table, and you have a foreign key, which is usually in the child table, or the parent table and the child table. In the child table, you'll have a column that's basically, maps to the primary key of another table. And this is where we have to be careful. Technically, a foreign key doesn't have to be a primary key in the other table. You could actually literally reference any other column. It's just because you can do it doesn't mean you should do it. Because at that point, you might not be referencing something unique and you might end up, having all kinds of problems. So normally it's primary key to foreign key. Source table is the primary key, and the destination table will have a foreign key. It's called a foreign key because the value in that field comes from a source foreign to that table. Like there's a value being put in that field. It has nothing to do with the data of the record. So, but it has a value and it's coming from a foreign source. It's coming from outside itself. Thus, it's a foreign key. So here's our two examples using the world database. In the world database, you'll remember that we have a city column, right? That's table. And we have a country table. The country table has a code column, which is its primary key, as we can see here, right? Now, in the city table, you'll notice that there is a country code column. And the foreign key name in the destination table is not important. You want to pick something that's obvious, and whoever designed this database decided they'd go with source table name, primary key put together. And this literally maps to here. So each country can have 0, 1, or more cities listed in it. That's why it's, one-to-many relationship here. And any value that's put into country code must exist in the code column in the country. If it doesn't exist in the code column in the country, it will give you an error. I think I actually demonstrated that when I was doing the inserts with the multiple columns, where if you try to insert something that was invalid, it generated an error. That would have been week 2, if I remember right. I did it. And that's literally what the rule was, is that's what was happening, is it's saying, hey, you're trying to put a value in this column. Let me go check my parent and see if you're allowed to put that value in me. It looks in the parent table and goes, either yes, the value is there, good, I'm allowed to put it in, or no, the value is not there, therefore you're feeding me invalid data. No, you're not allowed to do this. Too bad, try again. And you don't allow bad data to go in. So referential integrity makes sure that any data you put in, if it relies on something else, that something else already exists. It's a bit like saying, hey, you're going to have a class in building Z and Z235. There's no building Z. Therefore, the system won't let us put in Z235 as a classroom because it doesn't exist. Imagine if we could just put in whatever classroom numbers we wanted into your timetables. There we'd land at building Z, wherever that happens to be. I mean, there's a building V, but there's no Z. And if ever you wonder where building V is, out of curiosity, it's on the other side of lot 12 parking. So you go to lot 12 and you look at the far end, you'll see a little building at the end near the soccer dome. That's building V. That's where the veterinary technicians study. They actually have animals in there. Often they have dogs and cats. And they used to put them up for adoption at the end of the school year. So they were vaccinated, neutered, in good health. And you could, I don't know if they still do. It might be, if you're looking for a pet, it might be worth looking into that. But yeah, before COVID, you could adopt the pets from the vet tech program at the end of the year. You knew they were well cared for and healthy, if nothing else. But yeah, so that's what the foreign key does. You have two fields, one in each table, they're related to each other, and the database enforces the rule. The foreign key can be set to be null or not null, which means that value is optional, which means you can insert, when you go to insert a row, you have the choice of either putting in a null value into that field or a value that exists in the parent. So either you literally feed it the absence of value or a valid value. but you can't put whatever. An example of why you'd want a null on a foreign key would be, how many of you have ordered something from Amazon in the last 2 months? Okay, a fair amount of us. How many of us ordered something from Amazon like 2 days ago? 3 days ago? Unfortunately, I realized I needed two different things on 2 different days. Um, when you place your order, the shipping method is not set on the product right away until it ships. So at that point, the order product gets added, but the shipping method is null. When it's determined how it's going to get shipped to you, then the value gets applied. But it can only apply a value from their defined list that applies to whatever it is you're doing. So that's when you'd want a null. Okay, so in lecture 2, I showed you guys how to create a primary key where you could do it inline. So create table country, country code, car 3, primary key. Great, creates a table and it's a primary key. That works until you have a compound key where you have more than one field in the key. So you want to create it explicitly instead. So create table country, country code car 3, state code car 3, not null, and state varchar 50, not null. Then you can create a primary key that combines both country code and state code. So if you have to create what they call a compound key, a primary key made up of more than one attribute, you have to do it the explicit method, which is like this. Some database systems, MySQL and MariaDB don't, but some database systems actually require you to name your primary key. They'd be like primary key space, you give it a name, and then you have the parentheses. For example, Postgres is like that. Postgres actually gives you a choice of naming it or not, and there's advantages to naming your primary keys if you are planning to use query optimizing routines. MySQL doesn't have query optimizing routines, therefore it doesn't require you to name anything because it does what it does and it just does what it thinks is best. But if you need to add a primary key with a compound key, you do it the explicit way like this. Right, relationships. We did talk about this, I think, in the first lecture a bit. So there's 3 kinds of relationships in databases. One-to-one, and one-to-one I like using the student-to-locker example. Anybody here actually rent a locker? Every year I ask this, and every year there's fewer and fewer students that rent lockers. Okay, so in the system at the school, the relationship between a locker and a student is one-to-one. A student's only ever allowed to have one locker, and the locker is only ever allowed to be assigned to one student. They're 2 separate tables, but they are only allowed, it's a one-to-one relationship. In other words, for example, you're not allowed to go rent 2 lockers. Let's say you've got classes in B and T, and you don't want to carry your crap across the school all day. You say, I'm going to have a locker in both buildings so that, my classes on Monday and Tuesday are in B, so I can leave my jacket in B. My classes on Thursday are in T, so I'll use the one in T. No, they won't let you do that. You get one or the other. That's a one-to-one relationship. In this case, it doesn't actually make a difference where the foreign key is because it's one-to-one. So whether it's the locker ID that's on the student or the student ID is in the locker, that establishes the one-to-one. One-to-many, which is the most common type of relationship, would be your Amazon order with 3 things in it. You went to the grocery store and you bought 5 things. You have 5 courses. So one of you, 5 courses. I've got multiple courses, multiple sections, multiple students, but there's only one of me, right? You could turn around at my job and say, there's one of me and I supervise 14 people, right? So one to many. By the way, that's actually really ridiculous that it's 1 to 14. It's supposed to be like 1 to 6, but it's 1 to 14 right now. And then you have many to many. So many to many is a conceptual relationship. It's physically impossible to implement in a database. And you'll learn about that next semester, about how you fix the many to many. So an example of many-to-many would be employees and skills. You hope your employee has many skills, right? So relationship from employee to skills is many, and you're hoping that each skill has at least has more than one employee, right? So same one skill can go to many employees, one employee can have many skills, so employees to skill is a many-to-many relationship. Um, it's very common in the design phase. It is physically impossible to implement. Like when you get down to the point where you're creating the physical database design, many-to-many does not exist. It's resolved using other techniques. Um, so since the most common type of relationship is one-to-many, that's what we're going to do today. Because here's a secret trick. Inside the database, one-to-one and one-to-many is the exact same thing. They're created the same way. They behave exactly the same way. They are for all intents and purposes, identical on the inside. One-to-one and one-to-many is a business rule where it's the rules of how the data lives. There's nothing that stops, again, back to my student and locker. In the database, very likely there's nothing that stops. I don't know how they have it implemented at the college here. So, I'm just going to assume that the student ID is the foreign key on the locker. There's nothing that technically stops a student from having more than one locker in the database. They have a business rule that says it's one-to-one. Okay. Um, so when you create the relationship, you can create it when you create the table, or you can add it on after the fact. Okay. So here's our two tables from our world database, country and city. Again, country code is our primary key. It's this bad boy right here. And we're going to create our city table. So ID, it's an int, auto increment primary key. Name, varchar 50. Country code, car 13 not null, because we're going to require the country code to exist. We are going to add another comma. So if you remember when we were looking at this one here is just primary key, right? If you're going to add a foreign key, you actually start with the word constraint. Constraint says this is a rule. Then you give it a name. The name is not important as long as you stay consistent. You can call it dog and it won't care. But you tend to want to at least give it a name. Then you'll do foreign key, and then you name the field that participates in the foreign key. You'll notice that this part here, let me just change the color of my marker because everything's in red on there. So I'll go to blue. This value here is found in this table here. So you're saying foreign key, and then you'd say, here's the column. By the way, you can do more than one column. You can have a multi-column foreign key, because if the parent table has a compound primary key, the foreign key is going to be compound also. Then you say it references. So now so you're telling it, hey, the country code, you're going to find it. It's going to reference the country, and it's going to use the code from it. So it says it references this table, and it's going to grab the code from the primary key. And there's a little bit more below that. So everything else after that point is optional. The on update cascade and on delete cascade. I'll be explaining what those are in just a moment. Or actually, yeah, there it is right there. All right. So on delete cascade. So what that clause means is when you delete a parent record, it also deletes the child records automatically. Normally, if you have a foreign key, you delete the parent record, you can't delete the parent until you've deleted the child records first. So you actually have to go down the tree of data and delete from the bottom and work your way back up. So you can't kill the parents unless you kill the kids first. Cascade, on the other hand, means when we take out the parent, it takes out the children at the same time, and it'll cascade all the way down. As long as there's cascade rules everywhere, you will it will cascade down. So in the world database, if we had the cascade rule set up and we delete Canada, it would delete all the cities that belong in Canada automatically without even saying a word. It would just gone. It would just say record deleted. Congrats. And then you wonder where all the cities went. In a production environment, on delete cascade is very rare because it's too dangerous. You will use it for some things. You might want to you'd use it on tables that are not of business value. Um, for example, you want to delete a user. You might want to, if we have a log that goes with that user, we might want to nuke that log also, so then it would cascade and delete that stuff. But you don't want the ability to delete, for example, you've got an order and order lines, you do not want the ability to delete an order if it has products in it. Therefore, you can't go delete star from, just delete from order where ID is equal to 55 and just let it delete everything, because there's probably a reason why you have that order in there. There needs to be rules to be put in place for that. On update cascade is for changing the value of the foreign key. If you use a numeric foreign key like you really should, then on cascade, update cascade, you don't have to worry about. It's when you use a string-based primary key. So for example, in this example, we go to, okay, so let's say that we created the record and country code was set to Canada instead of CAN. If you do update country code from Canada to CAN, it would actually reach into the child records and update all the foreign keys for you. So you don't have to worry about updating the foreign keys, because it's actually really gross when you do that. Because realistically, what you have to do is actually add a new, what's happening is actually going to add a new record, temporarily change the values on the child, update the parent, and then update the child back to what the parent was, and then get rid of the temporary record. It actually temporarily assigns it somewhere else while it's doing the update. On update cascade just does it for you instantly, quietly, and it's not dangerous. Update cascade is safe. On delete cascade is dangerous. Now, you have options for this. On delete instead of cascade, there's actually literally called do nothing. So it's on cascade, do nothing. And what happens then is you try to delete something, it goes, brah, not allowed to. We're doing nothing. And it tells you you're error. So by the default behavior on delete is usually do nothing, not cascade. This cascade is just so dangerous. Okay, so referential integrity. Databases are aware of the relationships. They don't allow modifications that violate the integrity. So let's say you have a child record with a foreign key and you try to change the value of that foreign key to something that doesn't exist. It's going to say no. You try to insert something and you feed it the wrong foreign key. It's going to say no. You try to delete a parent while there's still child records. It's going to say no. That's what referential integrity means. It means it's keeping the integrity of the references, well, maintains the integrity. So it's like saying, hey, I've got a house, I'm going to pull out random 2x4s out of the walls. You're not allowed to do that. What's going to happen if you take out too many 2x4s out of your walls? House goes frush. Well, not a European house, but North American houses. European houses are built with brick, so it's not quite the same. But North American houses, if you pull out enough 2x4s, the whole house will collapse eventually. Therefore, the rule is you're not allowed to take out the 2x4s, so it maintains the integrity of the house. And there's an example there of that. The same thing with the foreign key. I just described it. There's just examples of what the error messages look like. Okay. Discard this. So the good news is today was short. It was literally the last bit of content for this semester. It's literally just filling in some of the blanks from lecture 2. I believe Safe had a chat with you guys in lab about the practical assessment. Again, make sure that if you need accommodations or whatever, that's all arranged. Um, the and that he's got the content for the test. He knows well what's in it. Um, to my understanding, he's going to be going through it a bit more with you guys, so you know what's coming. Make sure you do the practice test that was released to you guys, I hope. So try to do the practice test. It will make your life significantly better or easier or more straightforward. Um, the first time I ran this course, we didn't have practice tests and I didn't give them out. And the second time I ran this course, I gave out a practice test and there was a significant improvement. No, I'm not giving you the answers to the practice test. The practice test, I would say, is content-wise, is exactly the same as the real test. It's not like the practice test is, um, did you ever have people give you a practice test to do and then it looks nothing like the actual test? It's actually a test that we actually ran before that I'm never going to reuse. It's a real test. The new test, the test that you're doing this time has a few extra little steps in it for extra detail to make actually Saif's life easier. But the actual questions part is the same. So do the practice test, then time yourself. Like set a timer so that when you run out of time, you know that what you need to focus on. As for the written test, well, it's a written test. So I have no advice for that. Just come, put your stuff away, and write the test. And I'm gonna go, like I said, I'm gonna go through it next week in a bit more detail. Specifically, what types of questions, that kind of thing. But yeah, that's it for today. It's a quick one. And you guys get to, actually, this is your last class of the day, right? Yeah, so you get to go home early. Congrats.